Welcome to the video for lesson 4-2. Um, Hopefully you have done the prep skills for lesson 4-2. You'll notice we're talking about square roots. It's good to be able to take a square root, but also to know like the square root of 8 has to be less than the square root of 9, but more than the square root of 4. And particularly be able to do the graphing or do the square root on your calculator. Also remember the slopes of the lines that we've talked about, and things like that, and seeing how far apart different things are on a coordinate axis. And also hopefully you have read the introduction to 4-2. So having done all that, you are ready to go on and start the classwork. Do question 1 on the classwork. You'll notice a triangle there. When engineers look at a roadway, they imagine it to be on a coordinate axis. Then they refer to the grade of the road as the percent. Like 8% is typically the highest grade of the road that you can actually maintain. So generally roads tend to be 8% or less. The percent really represents the slope. It works just like slope, except that to make it easier to work with, we turn it into percent. So to get the actual slope, you turn it back into a decimal. Once you've answered question 1, restart the video and we will discuss it. Okay, so change in elevation over 1 mile if it's an 8% grade. So that tells me my slope equals 8% times 100, 0.08. So my rise over my run, we haven't really talked about that. A lot of times we call the change in y the rise. Y2 minus y1 is the rise. And in this case, we know our run is 5,280. And we are looking for our rise. I was trying to call it x like we do in our equations, because I'm going to solve an equation. I'm going to call it r for rise. Let's just call it y. And then we'll solve for that equation. So we know that has to be 0.08. And I'm going to multiply both sides by 5,280. Okay. And of course here, 5,280 divided by 5,280 leaves me with y. And that equals 5280 times 0.08, 422.4. That is feet. We're going to be using that a lot, so hopefully you are able to figure that out. And Actually, there's a did you get it that will help you see if you figure it out. So if you don't get it and you don't see why, let me know and we can figure it out. The other thing we're going to be doing with triangles today is what's called the Pythagorean theorem. Um, Normally, I like to start this class with an explanation, kind of a proof of where the Pythagorean theorem comes from. But the Pythagorean theorem is really just this right here, a squared plus b squared equals c squared. So if we have a triangle, we can find the hypotenuse. Well, first of all, let's talk about the sides. C is the longest in this, the longest side, and you'll notice it's across from the right angle. Right triangle has to have a right angle. C is across from that. So we call that the hypotenuse. And A and B are called the legs. And you'll notice that a squared and b squared are added together. It doesn't matter what order they're added in. What matters is choosing the hypotenuse. In that formula, the c squared is important. So I'm going to do a squared plus b squared. And I'm going to say a is 5. Even though that's different from the diagram, if I have my own triangle, it doesn't matter. I can label A and B either way. C is the important one. So 5 squared plus 12 squared equals C squared. I have 25 plus 144 equals C squared. That gives me 169 equals C squared. If I know what C squared is, and I want to find C, I can take the square root. That is the whole purpose of the square root. When we work with multiplication and division, if I want to see what I should multiply by, I use division. If I have 5 times x equals 10, I divide by 5 to get 2. Tells me that 2 times 5 gives me 10. Division tells you the answer. What do you multiply by to get this number? Square root is the opposite of squared. Square root of 169 tells me what I need to square to get 169. And that happens to be 13. So 13 equals C. Let me write it up here so you can see it in this case. So that's kind of how that works. Okay. Kind of go through, don't worry about the technology. As long as you can take the square root on your calculator. And I'll show you really quickly, square root of 47. Make sure you can do that on your calculator. On mine, I do 47, and then I have to do the second function, and that gives me the square root, and it has that little angle type thing. Looks a little bit like the divide, but it's straight instead of curved, and it has a 2 there. If the 2 is not there, it means square root. So anyway, I take the square root, 6.855, 655, 6.855, 6546. So as long as you can do that, you're ready for the lesson. Okay. Complete the following table of common square roots. You can probably do that without doing a lot of thinking, but try to think your way through it. And you'll notice then there's some samples where you have to estimate the square roots. So Go ahead and do that and restart the video when you're done. Okay, square root of 1 equals 1. That's because 1 times 1 is 1. Square root of 4 equals 2 because 2 times 2 is 4. I want to see what I take the square root of to get 3, so I do 3 times 3, I get 9. And yes, the square root of 9 is 3. Square root of 16 equals 4. Square root of 25 equals 5. What do I take the square root of to get 6? Well, that's 6 times 6, or 36. Square root of 49, you can probably guess, even if you don't remember, that 7 times 7 is 49. You probably guess the square root of 49 is 7. Square root of 64 is 8. Square root of 8 is 9, because 9 times 9 is 81. Square root of 121 is 11. And as I showed you before, the square root of 144 is 12. Actually, I showed you that 12 squared is 144. And we saw that 169, square root of that is 13. 196, square root is 14. It's kind of interesting. I always thought. And the square root of 225 is 15, because 15 times 15 is 225. So if you look at the square root of 11, it has to be more than the square root of 9. Actually, it has to be more than the square root of 10. I'm sorry. So it has to be more than the square root of 9, but less than the square root of 16. Okay, so square root of 11 is going to be between 9 and 16. And it's closer to 9, so I'm going to say it's approximately 3.1, just as an estimate based on that. Square root of 78, a little bit less than 81. 78 is close to 81. It's considerably more than 64, so I'm going to say 8.9. Square root of 99, that is going to be very, very close to 10, but less than 10. I'll say 0.9.9, and it's probably more like 9.99. You can do that on your calculator and figure out what that is. 124, that's a little bit more than 121. So I'm going to say 11.1, just as an estimate. Hopefully you do these on your calculator. You'll see how close my estimates are. Purpose of this is to get you to think about what's a reasonable number. Helps you make sure that you enter your calculator, enter things in your calculator correctly. Okay. Okay, so look at the Pythagorean theorem to study grade. So go on to question 3. Restart the video once you've answered question 3. Okay, so diagram on page 471. I'm pretty sure that's the triangle there, the 8% grade. So use the Pythagorean theorem to write an equation involving the length of the missing side of the triangle. Then simplify the side with only numbers on it. So we got 5,280 for one side of our triangle, 422.4 for the other side. And when we talk about grade, we're taking the vertical change in elevation divided by the horizontal length. Vertical and horizontal always give you a right angle. So when you're talking about vertical and horizontal, when you have a story about the Pythagorean theorem, vertical and horizontal give you the right angle. So I actually have my side across, the side that's missing is the C. Okay? So I know that 5,280 squared plus 422.4 squared equals C squared. And I can go to my calculator now. So 5280, and I don't want my second function button this time. I already have the x squared, the x with a little 2 above it. So that gives me the 5,280 squared. I'm going to store that in my calculator. It says MS for memory store. Now I'm going to take my 422.4 and I will square that. Actually, I'm not going to write those two numbers down because they're really big. I'm just going to take the 422.4 squared and I am going to add, and I push the memory recall button, the 5,280 squared. So I've added my a squared and b squared. That equals my c squared. So 28,056,822. That's all equal to c squared. If I want to find out what c is, I have to take the square root of that number. And in line with our equation solving, you notice I take the square root of both sides. So that tells me what c equals. So now all I have to do is take the square root. And since I already have the number on my calculator, I can just push the square root button. I get 5,296.9. And I should write feet, but I don't have room for my big fat pen. Question 4. I'm sorry. I've already done question 4. So question 4, we take the square root of both sides. So find the missing length. So do question 5. So question 4 is c equals 5,296.9 feet. So question 5, how much further would you drive if it had been, how much further do you drive because you're going up the slope than you would have if it had been level for that mile? Okay. One thing on engineers, when engineers look at roads, they look at the horizontal distance. So if an engineer sees a mile of road, it's the horizontal distance, not the actual driving distance. Okay, so that's the question here. How much farther is the actual driving distance? Okay. Restart the video once you've done that. So how much farther? That kind of tells us we need to subtract. Equals 16.9 Feet. Okay. Another did you get it? Check and see. If you don't get it and you don't know why, send me an email. Okay. Start the group work now. Restart the video once you've answered question 1. Okay. Suppose that we know the distance between 2 points is exactly 5 miles. If the contour of the road followed a solid path in each of the 3 figures below, would the distance traveled by the car be more or less than or equal to 5 miles? So as I was saying, engineers look at the horizontal distance. So they're saying 5 miles from A to B. So this is 5 miles, and this is 5 miles. And what you're supposed to notice is that the shortest distance is going to be this one. If you have this situation, you'll actually drive further going this way. Okay. Let's go on to question 2. So they're talking about contour maps. Contour maps show horizontal distance, but they also show vertical distance. So in this case, you have something that is 10 meters above sea level. This every point on this line is 20 meters above sea level, and these are all 30 meters above sea level. So the tip of the mountain is actually a little bit above 40 meters above sea level. Probably feet. Looks like they're doing it in feet. So feet above sea level. Use that when you answer question 2. Restart the video once you're done. Okay. So we've got the contour map there. How does the distance between points P and Q compare to the distance on the map, between the points M and N on the map? Use the scale on the map. So P to Q and M to N are both about 200 feet. Of horizontal distance. Okay. Restart the video now when you've answered question 3. The lower illustration shows also shows points P, Q, and M and N. The lower illustration is what we call a cross section. So the gray line. Imagine you cut the mountains at that point, and you look at them from the side. That's what you see in the bottom portion. So how does the actual hiking distance from P to Q compare to M to N? So if the horizontal distance is the same, P to Q, you're going to climb more or climb less vertically. You go from 20 to about 40. But for M to N, you go from 10 to over 50. So you climb about 20 feet going from P to Q, but you climb about 40 feet going from M to N. As a result, the actual distance M to N is greater. And hopefully you see that from the drawings that I made there. Okay. Same thing with question 4 now. Restart the video once you've answered question 4. Okay. Based on the scale provided on the two-dimensional contour map, the distances from P to Q and M to N are both about 200 feet. Use the lower illustration to estimate an actual trail length between the points P and Q, making sure to describe how you got that estimate. Then repeat the trail between points M and N. Okay. Actually, the way well, whatever you did to get that estimate is probably reasonable. What they're hoping that people will do is say, from P to Q, I go, so the actual distance from P to Q from P to Q, I go 200 feet horizontally, and I go 20 feet vertically. Okay. So we can actually use the Pythagorean theorem to calculate that value. So 200 squared plus 20 squared equals 40,400. So the distance from P to Q squared equals 4,400. As before, doing the same thing to both sides, I can take the square root of that distance and take the square root of 40,400, and I get the distance from P to Q equals second function square root 201. So not a lot of difference. If I do the same thing though with M and N, (200 squared, because it's still 200 horizontal feet, plus 40 squared, because I go from 10 to a little bit, 10 to about 50. So that's 40 squared. But that gives me the square of that distance. So for 200 squared plus 40 squared, 41,600. And if I know that the distance squared is 41,600, I can take the square root of that, and it actually gives me the distance from M to N. I'll go back to my calculator. Second function square root. That's actually 204 feet. So the walking distance from P to Q is 201 feet. The walking distance from M to N is about 204 feet. Okay? So it makes a little bit of a difference, not enough to really worry. Okay. Question 5, illustrate each trail by drawing a triangle. Question 6, actually, question 6 is what we've just done, is using the Pythagorean theorem to estimate those. So, the road sign, let's go on to question 7 then. The road sign at the beginning of this lesson is from a road with an 8% grade for a horizontal span of 8 miles. By how much does the elevation change over that 8-mile span? Restart the video once you've answered that question. All right. So we've got a really long triangle here. And 8 miles. I'm going to go ahead and call it 8 miles. Wouldn't be a bad idea to change it into feet, because you avoid a decimal. But if you leave it at 8 miles, you avoid a big number. So I'm going to call this side B. I'm going to say B divided by 8. That's my slope. B is the change in y. 8 is the change in x. Equals 0.08. If I multiply both sides by 8, I have 8 divided by 8, which is 1. I'm just left with B. 0.64. So you go up 0.64 miles in that space. Okay. Based on that, you can now answer question 8. Restart the video once you've done that. Okay, how far would you actually drive? They're asking now for this distance. Remember, we have a right angle here. So we know that we can take eight squared plus 0.64 squared, and that will give us c squared. So I go to my calculator. 8 squared is 64 plus 0.64 squared. 64.4096 miles squared equals c squared. I don't want c, I want to know the number of miles, so I have to take the square root of this. Taking the square root of 64.4096 is going to give me the square root of c squared. And the square root of c squared is just c. Then I do my square root. I get 8.025, we'll call it 8.026. So the actual driving distance is a little bit more. Go on to question 9. Okay, now that you've done question 9, before selling his house, Brian needs to remove a dead mouse that got trapped under the bathtub. includes a deceased animal is not a feature buyers are looking for. Using the corner of the room as the origin and using a patented high-tech rodent corpse location device, he was able to determine that the mouse was located at coordinates 4 and -2. An access panel under the sink is located at coordinates 1 and -5. Assuming that the units are feet, the goal is to find the distance from the access panel to the mouse. Okay. So if we look at x is 4, y is -2, they're kind of showing that here. The access panel is at 1 and -5. Okay. So we go to the graph. 1, 2, 3, 4, and -2 is where the mouse is. 1 and -5. 1 and -5 is where the access panel is. So we're actually trying to find this distance, the distance between those 2 points. And it's telling us make an estimate. I'm going to imagine that I'm swinging this down. I don't want to give it away again by doing the Pythagorean theorem. But if I swing this down, if I just make a circle, I'm going to end up at 1, 2, 3, 4, about 4.5. So about 4.5 feet. Huh? And let's go on. And in fact, question 10 does ask us to calculate it using the Pythagorean theorem. So go ahead and do that. Restart the video once you're done. Okay, if I look at the graph, I have 3 feet for one of my legs. When you have a coordinate system, you're always going to have a right angle. It's one of the nice things about the coordinate graphs that we use. And I'll notice I have 3 feet here also. And in this case, you could actually do that by doing x2 minus x1. So x2 is 4 minus 1 gives us 3. And then y2 minus y1. So if the 4 is x2, it has to be y2 as well. The -2 has to be y2. So we have -2 minus -5, which gives us a +3 because we subtract a negative, we get a positive. At any rate, they're both 3 feet. So we have c squared equals 3 squared plus 3 squared. C squared equals 9 plus 9. C squared equals 18. And doing the same thing to both sides, I take the square root of c squared to give me c. That's just left with c. And then I have 18, second function square root, 4.2 feet. Okay. I'm going to do classwork again. So go ahead and do question 1 on the classwork and restart the video once you're done. Okay, the process used to find the distance from the access panel to the mouse in group question 9-10. Okay, so the coordinates, we're actually going to start working with um, uh, just using variables again. This is what we called literal equations before. So we're going to be doing some math and not getting any answers. So anyway, try question 1. Restart the video once you've done question 1. Okay. So first, question number 1. What are the coordinates of the point where the dotted lines cross? And obviously you can't put down a number because we don't have any scale. So we're just working with variables. So we want to look at the value of this. First of all, it's on the same line as the point x2, y2. So the first coordinate is going to be x2. And if I look at the y value is not going to be y2 because that's up here. But this happens to be on the same line as the y1, x1, y1 point. So the point at the corner is x2, y1. I'll rewrite it here where I have a little bit more room. Okay, that's the point right at the corner, and you'll notice it happens to be the right angle of our right triangle. So try question number 2 now. Restart the video once you've done question number 2. All right. Question number 2. Use your answer to question 1 to find the length of the 2 dotted sides. And just for simplicity, I'm going to call them A and B, so I don't have to draw on the picture anymore. So A, I can take my x2 minus my x1. The length of side A is just this length down here. So A equals x2 minus x1. And B equals y2 minus y1. Okay. So those should look similar to what you've seen in the slope formula because we're calculating the same things. We're calculating the length of those sides, but we're going to use them differently. So go on to question 3, and once you've answered question 3, come back to the video. Okay, question 3. We now want to calculate D based on A and B. So it gives us a hint that we need to put parentheses around our expressions. So actually D squared equals A squared plus B squared, or D squared equals x2 minus x1 squared plus y2 minus y1. And you notice we have to put the parentheses, otherwise it would just be y1 squared. It would not be the difference squared. Okay. Go on to question 4. Should be pretty straightforward. If you don't see what to do right away, come back to the video, but I think you can figure it out. So Restart the video once you've done question 4. Question 4, we have d squared equals x2 minus x1 squared plus y2 minus y1 squared. As we've done before, if we know d squared and we want d, we need to take the square root of d squared to get d. So d equals square root of x2 minus x1 squared plus y2 minus y1 squared. And that's what's commonly called the distance formula. You'll see that's kind of in the summary here. You just want the distance between 2 points. You can use the Pythagorean theorem. You don't really need to memorize that formula. I always use, when I use it, I just think my way through it. I want the lower side, so I do x2 minus x1. I want the rise, the vertical side of the triangle, I do y2 minus y1. I just square those two numbers, add them together, and then take the square root. It's the same as any other application of the Pythagorean theorem. Question 5. Restart the video after you've done question 5. Okay, a map of a national park has a grid on it to help reference locations. The camping office is located at the point -510 on the grid, and the lodge is at 2, 4. Each square on the grid represents a distance of 2 miles. Use your formula from question 4 to find the distance from the camping office to the lodge. When you look at a map, north is up. So north and south are in the y direction. East and west are in the x direction. So we'll use our formula now to find the distance between the two places. So I don't know what it's going to look like, but I know to find my A and my B, to find my A, I take the difference in the x values. So A equals 2 minus -5. Which equals 7. B equals 10 minus 4. I did that wrong. So I take 2 minus -5. Then I have to take 4 minus 10. Which is going to be a -6. So in actuality, the triangle should probably go upside down. But it doesn't really matter. It's just for a conceptual idea. So I'm going to take D now, and that's going to equal 7 squared plus -6 squared, which is good because it will give us a chance to talk about how to use your calculator. Anyway, so I am going to the calculator. 7 squared plus 6, and I push my negative button to get my negative, and then I square it. I get positive 36. You have to be careful on some calculators. If you put the negative before you put the 6, If your calculator wants you to put negative and then 6, and you square that, most likely you will get negative 36. What your calculator is doing is squaring the 6 and then making the 36 negative. If you square negative 6, you do negative 6 times negative 6, the answer is going to be positive. So if you square negative 6 and you get negative 36, then that tells you your calculator wants you to put the negative 6 in parentheses and then square it. Okay. So I get 85. When I add those two, I take the square root of that, and I get 9.22 coordinates. And some people may forget to go on from there, but that's grids, or squares on the grid. And each one represents 2 miles. So I have to multiply this by 2. And I get 18.44. D equals 18.44 miles. And if you just plug these numbers into the formula, you didn't draw the picture that I did, you didn't do it the way I did, as long as you put the parentheses and you did your PEMDAS, you did your parentheses first, then the exponents, then the addition, and then the square root at the end, because the square root sign works like parentheses. You have to do everything under what we call the radical before you do anything else. So you do the square root last because it works like parentheses. Anyway, nothing wrong with that. If you did that, that's fine. I was just trying to show you that you can think through the problem. So did you get it? So find the distance between those 2 points. Remember, each grid represents 3 feet. So if you didn't get it, send me an email, and hopefully we can figure out why. But anyway, that gets us to the portfolio, which, remember, do your ALEX. Online practice is the ALEX. Make sure you do that. And the applications, want to do the applications. And then do the looking ahead. Make sure you do the looking ahead. Okay. One thing on the applications, a lot of it is kind of the same as before. It's not a huge deal. Actually, it's all kind of the same as before. I'm going to give you an archaeological dig with grids, kind of the same as what we did. This one seems to give people problems. There's kind of an explanation of the roadway, the bridge, and there's a question about the bridge. And the author's trying to figure out how long the bridge is. He's actually using the pixels. He measures the pixels in the picture. If you look really closely at a digital picture, if you zoom in really far, you see squares. Those are the pixels. If you zoom in really close, you start to see the pixels. You don't see the picture so much. So he measured the length of the bridge in pixels. Okay. And he has the average length of a car, which was 34 pixels. So you can figure out how long a pixel is, and then so how long is that span in feet? So we're actually talking about a proportion here. So we can do that. And then once you have that length, he notices, find the vertical height when driving the length of the bridge, gives you that, the 89.6. And if you look at the bridge, the 89.6 is here. And you calculated the span in question 5. Now you have the span is this distance here. You have this distance, you have the span, and you need to calculate the length. Okay. Question is then, do you think that's an 8% grade? So once you have the vertical height and the horizontal length, you can calculate the percent grade. And that's what they're asking you to do in these questions. So hopefully you can work through that. If you have questions, let me know. Be happy to exchange emails with you. Thank you.